All right, this is 5.2 part 3, half angle formulas. Now, the first thing is that these formulas are listed here, and they're also on page 594 of your book. And let's just take a minute and look at the formulas for a second. For sine and cosine, you're going to notice this plus or minus in front. Now, you're not going to use both positive and negative. You're going to have to pick one. And how are you going to know which one to use? What you're going to have to do is to determine the plus or minus, you have to decide what quadrant. You're going to have to decide the quadrant your half angle's in. Then you're going to have to use the correct sign from there. So the plus or minus is going to be determined by the quadrant of your half angle, okay? So not by the quadrant of alpha, but of your half angle. Not of alpha, but of alpha divided by 2, your half angle. So let's just go ahead and take a look. Now also one last thing is that tangent, notice tangent has 2 different formulas, and you can use either one. All right, so here's the first one. We're given a sine being 3/5, and we're supposed to find the sine of theta divided by 2. So that means we're going to use the top angle, the top formula there. Now, let's start by drawing a picture because I'm going to need to know the cosine of alpha or the cosine of my angle. So I need to draw the picture first and find out cosine. My angle, my theta, is between pi over 2 and pi. So it's here in quadrant 2. Now, sine is opposite over hypotenuse, so we're going to get 3/5, and this is a 3, 4, 5 right triangle, so -4 is on the bottom. And I know cosine is adjacent over hypotenuse, -4 over 5. Right now, I'm trying to find the sine of half that angle. So not of theta, but half of theta. And I can use the formula. Now, the first thing I have to decide is, do I use the positive or do I use the negative? And remember I told you have to look at the half angle. Let's just take a minute and think about my angle. My angle right now, theta, is in quadrant 2. Let's just pick a random angle in quadrant 2. Let's use 120 degrees. Now, 120 degrees could be theta, and I don't know for sure. I don't know exactly what theta is, but let's just say it's 120 degrees. If theta is 120 degrees, that's in quadrant 2, how much is half of that? Half of 120 is 60. That means that theta divided by 2 must be in quadrant 1. If you take any quadrant 2 angle and cut it in half, you're going to get a quadrant 1 angle. Since theta is in quadrant 1, I know by my all students take calculus that sine is positive in quadrant 1. That means I'm going to use the positive version of this formula. And we're going to have 1 minus cosine theta all over 2. If I plug in what I know, I get 1 minus -4/5 all over 2. 1 whole is 5/5, so 5/5, and minus and negative is going to turn into plus 4/5 all over 2. If I keep going a little bit further, we're going to get the square root of 9/5 over 2. Dividing by 2 is like multiplying by a half, so we're going to get the square root of 9/10. If I square at the top, I get 3, and on the bottom, the square of 10. And I can do a little more rationalizing and get 3 root 10 all over 10. So that's the exact value of the sine of theta over 2, half of theta, if the sine of theta is 3/5. Let's go ahead and take a look at another example. We're given the tan of theta to be 1/2. Theta is between pi and 3 pi over 2, and we're supposed to find the exact value of the cosine of pi over 2. Let's go ahead and start by drawing a picture. We're in quadrant 3. We have the opposite side to be 1 and the adjacent side to be 2. They're both going to be negative because the x and the y are both negative in quadrant 3. And if you do the Pythagorean theorem, you'll get the radius to be the square root of 5. This is the same triangle actually that we used in yesterday's video. So if you're not sure how to get the square root of 5, go back to yesterday and you'll see that. Now, I'm all set. I'm going to need the cosine of alpha in my formula. So I need the cosine, and I'm sorry, we have theta here. The cosine of theta is adjacent over hypotenuse, so we get negative 2 root 5, or negative 2 root 5 over 5, when we rationalize. And now we need to decide if we should use the positive or the negative version of this formula. Let's pick a theta in quadrant 3. Let's just pick any angle in quadrant 3 to use as an example. I'm going to pick 200. 200 degrees is in quadrant 3. So theta divided by 2 is 100 degrees, and 100 degrees is located in quadrant 2. So if I take half of a quadrant 3 angle, I get a quadrant 2 angle. It means my half angle is somewhere up here in quadrant 2. Now, if I look again at all students take calculus, I'll notice that in quadrant 2, cosine is negative. So that means for my cosine of theta divided by 2, I'm going to use the negative version of this formula. Now I have 1 plus cosine of theta, negative 2 root 5 over 5, all over 2. The hard part is probably the simplifying from here, so let's just go through and look at what we have. 1 whole is 5/5. So we're going to get 5 minus 2 root 5 over 5. That's the numerator. The denominator's 2, all over 2. Now, dividing by 2 is the same thing as multiplying by 1/2. So we get 5 minus 2 root 5 all over 10. If I look a little bit further, I can't really do much else. For this class, we don't normally like to leave a square root under a square root, but for this class, we'll say this is far enough. So we'll just leave our answers right there at negative 5, the square root of 5 minus 2 root 5 all over 10. And that would be our exact answer. Moving forward. Again, find the exact value. Now this time, I just have cosine of 15 degrees. The problem is that 15 degrees isn't on my unit circle. But I do know that 15 degrees is 30 divided by 2. And 30 degrees is on my unit circle. I can use my cosine half angle formula now. The one thing we have to decide is our half angle, 15 degrees, what quadrant is that in? It's in quadrant 1, so cosine is positive in quadrant 1. So I know I'm going to use the positive version of my half angle formula. Now it's going to be 1 plus, and the nice thing here is my alpha is 30. So we have 1 plus the cosine of 30 divided by 2. The cosine of 30, looking at the x value, is the root 3 over 2. all over 2. I just have to combine some fractions now. 1 whole is 2 over 2. So we get 2 plus the square root of 3 over 2, all over 2. And dividing by 2 is like multiplying by a half. So we're going to get 2 plus the square root of 3 all over 4. And it's the square root of all that. Now the last thing I see is that if I take the square root of the top, I get this. And if I take the square root of the bottom, I get 2. And we'll just leave it like that. Again, normally we don't like to leave square roots under square roots, but for this class, we'll say that's good. Looking at the next example, tan of 3 pi over 8. Again, 3 pi over 8 is not on our unit circle. But if I actually, just like over here, I doubled the 15 to get 30. If I double 3 pi over 8, if I double this, I get 6 pi over 8, which is 3 pi over 4. Now 3 pi over 4 is on my unit circle, and that's in quadrant 1. Now, we can go ahead and pick either of those tangent formulas, and we can use that. So let's pick the second one. Let's use this one here. If I use that now, I'm going to have the sine of 3 pi over 4 all over 1 plus the cosine of 3 pi over 4. What I want you to do right now is I want you to find what all those are on your unit circle, and I want you to finish this example out and simplify. We'll go over this one tomorrow in class. The last thing I want to do is verify one identity using these formulas. So let's go ahead and look. On the left side, I have tan of x over 2, and on the right side, I have cosecant minus cotangent. So I'm going to go ahead and start with the left side with my tan of x over 2. And I think I'm going to use the first formula for tan. The reason is because the first formula has a minus, and if you look, my goal has a minus in it. So let's go ahead and put that in there. I'm going to get 1 minus the cosine of x all over the sine of x. Now I see a fraction, and I'm trying to get 2 pieces in the end. So I'm going to break up my fraction into 1 over sine x minus cosine x over sine x. 1 over sine x is cosecant, and cosine over sine is cotan. And it looks like we got exactly what we were looking for. This is where we're going to end today's video, and we'll go over that last example from the previous slide the next time I see you in class.